So, we're looking at functions. This should be pre-algebra. You would have learned this at a pre-algebra time of your life. So, a few vocabulary words. We're going to talk about relations, functions, domains, and ranges. You have to know those 4 words in order to determine whether a relation is a function and state its domain and range. You can't do any of that if you know what the words are. So, here's the words. Word number 1 is relation. I can get my magic pen out now. A relation is just pairing x's and y's. You often think of those as coordinates, like 2 and 3. Or in a table, you'll often see them like this. 2, 3, 2, 4. Can you guess what the next one is? That kind of followed a rule, didn't it? Pairings can follow a rule. They can also be absolutely random. 2 and 7, 3 and 2, 4 and 1. I don't know if that followed a rule or not. I was just kind of putting them together randomly. Sometimes when we graph these, we connect the dots too. Just depends on the situation. So these can be graphed, you connect the dots. It could come from an equation. Like I could have this equation. I think I've seen it somewhere before. Could you make a table of values? Would you get an x that goes with a y? Could you graph it? So that's what a relationship is. It doesn't have to come from an equation. It can. It can be shown a lot of different ways. Very long, long time ago you learned this. Probably forgot it. Kind of what you think these go together. So that is what a function is. Just x's, y's. You can show them a lot of ways. Relation. Oh, you're right, thank you. You're paying attention. I was just checking. Never been able to pull that off. Alright, so that's the relation. Function. A function is a relation where each x gets only one y. I always like to tell it that if you think of x's like X chromosomes being girls and y's being the Y chromosome, guys, each girl gets only one guy. Girls can't cheat. So is this a function? Because look at this girl. Look at that girl too. Good Lord, look at her. She's going with 3, she's going with 4, she's going with 5. What is her deal? Lots of free meals. So my mama told me when I got divorced, she said, don't you worry, someone will always buy you dinner. That's my mother. Okay, so what about this one? Is this a function? 2's going with 7. No one else? 3's going with 2. How come you can use the same number here? Yeah, think about guys and girls that have the same name. Same thing. You know, like Bob and Bob. Oh, wait, no. Alright, and 4 goes with 1. So that is a function. So it's the issue of who gets to cheat. What about this one? X, Y. 1 goes with 3. 2 goes with 4. 3 goes with 3. Function or not? You decide. Are you sure? 1 goes with 3. Is she seeing anyone else? 2 goes with 4. Is 2 seeing anyone else? This girl 3 goes with this guy 3. Is she seeing anyone else? So it is a function because none of these ladies are cheating. Notice this guy though. What a dog, I tell you. Guys can cheat in a function, girls cannot. It's a bad, bad world. Exactly. You don't see math in the real world. All right. So the next words we have to talk about are domains and ranges. And when we were in pre-algebra, we tended to say this. Look, the x's are the domain and the y is the range. That's what we used to say. And then I'd say, what's the domain? And people would go 1, 2, and 3. And I'd say, what's the range? And they'd say 3, 4, and 3. Which was a little stupid, because why would you say 3 twice? That's all right. They got better at it. Smart people said, do I have to write 3 again? But this is a kind of bad way to write domain and range. So let me show you a good way to write domain and range. I'm going to look at this equation. If I had 0 here for the x, what would y be? If I had 1 for the x, what would y be? If I had 2 for the x? Now, does that mean that for this relation, maybe function, that, sorry, I just got lost, that the domain is only 0, 1, and 2? Are you saying there's other x's that could be in here? What x's could you plug in? So 4, 5, 6, 7, can I plug in -1? I heard greater than 0 was a good guess. So can I put in -1?
Yeah.
Really?
Yeah.
What happens?
Y.
Oh, so I get a point out, right? If I plug in -1, I do get an answer, right? Okay. So if I graph all these points, I think we should have seen this. It looks something like this, right? So 0 has a point, 1 has a point, 2 has a point here, 3 has a point here. Does 10 have a point?
Yeah.
Yeah, up here somewhere, right?
Yeah.
How about -100, way out here?
Yeah.
Yeah, just because we can't see it, it's still there. So when we talk about the domain of this particular relation, we say that it is all real numbers. And I'm doing domain and range together, so you're going to kind of go back and forth with some of the examples. What about the range? The range is which y values have a point. Will y equals 0 have a coordinate on this graph? I mean, usually we plug in x's and get out y's, but could we work backwards? 0 gives you 0. Does y equals 1, this right here, does it have a point on the graph? How about y equals 2? Is there a point on the graph? Right there, when y is 2. What if y is up 3? Is there a point that's 3 high? How about 4 high? 5 high? 6 high? So how high do the y's go? How about how low? How low can you go? So I would say, since my y's can go all the way up and all the way down, every y going up and every y going down has some point, something that high on the graph, that it is also all real numbers for this graph. Kind of boring. But it's a lot better than when we were in pre-algebra and I'd say, what's the domain? And you just tell me the numbers you plugged in. Because that's not the only parts of the domain. There's a lot of numbers. Like negatives and positives and fractions and all kinds of crazy stuff. So let me give you another graph. I'm not going to give you the table this time. I'm going to give you the graph.
For range is also all real numbers?
Yes, because all the y's have a point. So the range is all the y's that have a coordinate on the graph. There. It's a new function. Oops. I need an eraser for that right there. So new function, see this one right here? What x's have coordinates on the graph? Like -10? Does that have a coordinate on the graph? How about -2? For x. Is there a point anywhere out here at -2? How about -1? For x's? Think x's. So this x value here of -1, are there any points out here? How about at 0? X is 0. X is 1. X is 2. Also, x is 2 is in the domain. X is 3. Is there a point on the graph where x is 3? That's 3 out. Like this one, isn't that 3 over? And also this one, right? Oh, look at that little vixen, that x. That x is 3 is seeing this guy. What's that y? How high is that y? About a 1, yeah, with a bad drawing. And look at her, this 3 out, that x is 3 is also seeing, that x is seeing 2 guys. What about x is 4? Is that in the domain? Okay. 5? 6? 7? So how would you describe the domain? Tell me what x's have points. Above? What about 2? Is 2 in the domain? Equal to. So our domain is all x's greater than or equal to 2. Every x value, everything out here, will have a coordinate. Or 2 or 3, you know. So that's how we say our domain. So domains are no longer just a list of numbers. It's, you kind of write them with graters and less thans. You say it's all these numbers. What about the range? What are the y values here? Can y be 0? Right here, right? Isn't that up 0? Could y be up 1? Can y be up 2? Does this have a height of 3 somewhere? Does this have a y value or a height of 4 somewhere? Well, not the way I've got it graphed, but if the arrow's pointing up this way, will it eventually? How about -1? -2? -3? And if that's pointing in that direction like this, so what are my y values? What highs and what lows will you reach? All real numbers. And so that's how we start to describe graphs now. As the domain is, if I tell you the domain is all real numbers, you know that it's going to go all the way to the left and all the way to the right, because domains are x's, which are left and right. If I say the range is everything bigger than 1, that means heights. So that means the graph starts at 1 and goes up somehow, and never goes below 1. So we can start to describe where this graph is. And finally, the vertical line test. Remember how I just pointed out that this was a naughty little girl, this 3, x is 3? Because if I were to write the table for this graph, when x is 3, y is 1. Or when x is 3, y is -1. And if you were to connect those and you had a really good drawing ability, it makes a vertical line test. The vertical line test tells you if it's a function. If you can draw it and hit more than 1 point, that means that girl's cheating. She's hitting more than 1 point. And there's a good little pun in there with hitting it. But anyways, she's hit more than 1 point, and so it is not a function. So vertical line test, looking at a graph, is the way to tell if something's a function.